Good evening, everyone. My name is Debbie McConnell, the Chair of AgriSearch. I take the opportunity of welcoming everyone to this webinar, which is delivered in partnership with AFBI and CAFRE on the subject of fertilizer planning. This is one of two webinars. This evening is dealing with dairy, and next week we'll be dealing with the beef and sector. The topic of fertilizer planning is particularly appropriate, and hopefully the timing is good for us, having regard to the dramatic increases in fertilizer prices. AFBI commissioned this piece of work to be done and commissioned AFBI. And we are very pleased to have with us this evening from AFBI, Debbie and David, and from CAFRE, Aveen and Robert. The chair for the evening is Sinclair, who many of you will know. And at this point, I will hand over and invite Sinclair to chair the remainder of the proceedings. Thank you.
Thank you, Seamus, and it's a pleasure to chair this very important webinar this evening, and great to see so many people signing in online, and hopefully there will be some useful information in terms of this whole challenge of dealing with the unprecedented increases in fertilizer price this year. Just before we start, we'll maybe start with some of the housekeeping rules. First of all, everyone's automatically muted as you join. So don't worry about any background noise, that won't be picked up during the webinar. We would really encourage you to use the question and answer function, which is at the bottom of your screen. If you scroll along the bottom of your screen, you'll see the Q&A button there. If you press that, then you can type in your question, and you can type in your question at any stage during the webinar, during the talks, or and ideally, so that we can deal with those then when it comes to the Q&A session at the end. If you have issues in terms of internet links and so on, usually what we find is if you leave, just press the red button on the bottom right and then rejoin, and that usually fixes them pretty well. The webinar will be recorded so that it'll be available on the AgriSearch, CAFRE and AFBI websites after this evening. And we would encourage you all to stay to the end. I promise we'll try our best to finish at 9:30 this evening. And we would like you to complete a feedback survey at the end, just to outline whether the webinar has been helpful, and also to maybe put in ideas, suggestions for future webinars or events of this nature. So that completed, we're ready to go. As Seamus has already mentioned, we've seen an unprecedented increase in fertilizer prices over the last number of months. And unfortunately, this will have major implications for production costs this year. However, grass remains our cheapest feed, and it's important that we look carefully at the implications of reducing fertilizer use, particularly if this ends up in resulting in a feed shortage next winter, which would be the worst case scenario that we could end up in. So we need to look very carefully at levels of fertilizer use. We also need to maximize our efficiency of using the fertilizer that is applied, and to look at other alternatives, particularly how to make best use of manure and slurry. And that's becoming an increasingly valuable commodity across all farms. So next slide, please, Gillian. We have 4 excellent speakers lined up to discuss these topics this evening. We start with the science, and Dr. Debbie McConnell from AFBI will present results of a recent review which was commissioned by AgriSearch back in the autumn when we became aware of the increases in fertilizer price. And Debbie will look at the cost benefits of fertilizer application. For paper 2, then we move to CAFRE, and Aveen McMullen will discuss the benefits of soil nutrient management for grass growth. And we stay with CAFRE for paper 3, and Dr. Robert Patterson will present a paper on practical on-farm strategies for fertilizer use on farms. And then finally, we move back to AFBI and conclude this evening with a paper from Dr. David Patterson, who will examine longer-term options for reducing reliance on chemical fertilizer. So if all goes to plan and our speakers have promised to stick to time, we will start our Q&A session around 9 o'clock. So please do type in your questions and we will pick those up then at 9 and aiming to finish around 9:30. So we'll move to our first talk, and that's the presentation from Dr. Debbie McConnell. Debbie is a dairy research scientist at AFBI, specializing in dairy grassland research, and she will discuss the results of her recent AgriSearch Commission review on the cost benefits of fertilizer use. So thank you, and over to you, Debbie.
Thank you very much, Sinclair, and good evening, everybody listening at home. As Sinclair mentioned, really what I want to do over the next 15 or 20 minutes or so was just take a little bit of a look at the cost benefit of fertilizer application, given the real increases in fertilizer price that we've seen in the last couple of months. Next slide, please, Gillian. Okay, so I suppose by way of background, nitrogen is obviously a key nutrient to us here in Northern Ireland in our grassland production systems. Our dairy systems and our dairy cows roughly eat in around the region of about 58 million tonnes of forage every year, be that either as grazed or ensiled grass. So it is a huge feedstuff that we have available to us. And obviously nitrogen, we are going to be reliant on nitrogen fertilizer to contribute to producing those high volumes of that forage. Northern Ireland at the minute roughly imports of about 342,000 tonnes of fertilizer per annum, and that's been declining over the last few decades. But a considerable proportion of that is still nitrogen, so about 86,000 tonnes of nitrogen coming into Northern Ireland each year. And so because of that, we're obviously quite exposed to outside fertilizer prices. Now, as we're all very much aware, in the last sort of 12 months, we have seen massive increases in energy prices. The graph on the right-hand side there just shows UK natural gas prices from this time last year up to January 2022. And you can see that in the autumn time, natural gas prices have really significantly rose. There has been a bit of easing back in January 2022, but how long that will stay, we don't know. But certainly there's been those rapid increases in energy prices. And because energy is such an important component of the fertilizer manufacture process, that has really impacted on the cost of producing fertilizer, particularly in Europe, where those energy prices increases have been felt the most. So what we've seen happen is a number of fertilizer production factories either cease production or reduce production quite significantly during the autumn period because of that. On top of that, we've had COVID disruptions to both the fertilizer manufacture process and to the transport infrastructure, which involves getting our fertilizers from the factory to the farm. So that's impacting as well. And around the world as well, we've seen a global reduction in fertilizer exports. So for example, China has reduced the amount of fertilizer they're producing due to the cost of coal, and we've seen Russia reduce their fertilizer exports as well. So it's all coming together in a bit of a perfect storm to really cause significant increases in fertilizer prices. Next slide, please, Gillian. And that's really what we've seen through autumn 2021 through to spring 2022. The graph on the right-hand side shows global fertilizer prices from 2008 to 2021. And you can see that really and the last data from that was entered in October of this year, and so we've seen further price increases since then. But you can see by the stage we'd reached October, we're probably sitting at a 10-year high globally in terms of fertilizer prices. So really that certainly has been an unprecedented lift. Now, there is a high degree of uncertainty for prices for 2022, and we don't know what will happen there and whether there's opportunity for those to come down. What we do know is prices at the minute are still holding quite high. And because of that, then we've got some key questions. So how does that increase in fertilizer price impact my overall cost of producing forage? Because it is such an important component of the forage production system. Is it still cost effective then to spread that fertilizer, given that it has gone up so much in price? And if we are going to spread any fertilizer, how do we maximize the value of that? So really tackling the first one of those questions, Gillian, if we move to the next slide, please. What impact does fertilizer price increases have on the cost of producing forage? So if we look at either grazed grass or grass silage, fertilizer costs typically account for about 25% of grazed grass, the full economic cost of producing a kilo of grazed grass, 12% or 18% of the full economic cost of 2-cut or 3-cut silage systems respectively. It's slightly higher. Fertilizer accounts for a higher proportion of the cost in grazing systems because more than nutrients in that system is supplied by artificial fertilizer compared to slurry, which has more of a role in silage systems. And what we can see, and these are full economic costs, so there is a land cost included here, is that if we've got fertilizer costing about £300 a tonne, on the graph on the right hand side, we can see it costs us about £84 a tonne to produce a tonne of grazed grass, 146 and 169 for 2-cut and 3-cut silage systems, respectively. That equates to roughly about £42 a tonne in terms of cash cost for grazed grass, and somewhere between £70 and £94 a tonne for silage in terms of cash costs. What happens, however, when we increase canned fertilizer prices for £300 to £600 a tonne, roughly equates to somewhere in the region of £11 to £22 increase in forage production cost per tonne of dry matter. And when we multiply that up to the impact that will have over a typical grazing platform, say you take a 40-hectare grazing platform, that equates to an increased energy or increased expenditure of about £8,940 per year. And under a silage system, again on a 40-hectare silage platform, the increase in that cost from £300 to £600 a tonne for canned fertiliser means we've got an extra spend of about £5,000 under a 2-cut silage system and just shy of £8,000 per year on a 3-cut silage system. So as we can see, the overall price of fertiliser is having quite a significant impact there on what we are going to spend over the course of a year in terms of producing forage. So it's really important then that we understand whether or not that fertiliser is good value for money, and we will get that return in terms of the grass value that's being produced. And I suppose one way to do that and how we start assessing that is to look at the nitrogen, the grass growth response that we get to the nitrogen that we apply. So Gillian, if you move to the next slide. So really what we have been looking at here is sort of nitrogen response curves, and basically what we're looking at is the grass response that we get for every extra kilogram of nitrogen fertilizer that we apply. And the graph on the right hand side is a very typical grass growth response curve for us here in Northern Ireland. So on the bottom axis we've got our nitrogen application rate, and on the vertical axis we've got grass dry matter yield. And as we expect, as we increase our nitrogen application rate, our grass dry matter yield increases as we go up. But it's not a straight line. There is a curve in that line and it does flatten out. So if we look at a couple of different points on that line, the first star on the left hand side there is 150 kilograms of nitrogen per hectare application rate. At that stage, when we apply every extra kilo of nitrogen that we're applying there, we're getting about 26 kilograms of grass dry matter back. When we move upwards to 300 kilograms of nitrogen per hectare, that response rate starts to fall quite significantly. At that stage, we're only getting 15 kilograms of grass for every 1 kilogram of nitrogen fertilizer that we apply. And then when we get up into very high rates of nitrogen fertilizer application, 450 kilos of nitrogen per hectare, we're only getting 5 kilograms of grass for every additional kilogram of nitrogen that we're applying at that stage. So what we're really seeing is that obviously as fertilizer application rate increases, nitrogen response rate decreases. And once we get above 300 kilograms of nitrogen per hectare, we are seeing significant reductions in that nitrogen response rate. And that's really because at those higher nitrogen application rates, other factors such as soil temperature, the light levels, soil moisture, they become a lot more limiting. Whereas at the lower nitrogen application levels, nitrogen tends to be principally one of the most limiting factors that's there. And I suppose, but what we see is that grass growth response to fertilizer is incredibly variable, and it's influenced by a range of factors which vary significantly between farms, within fields, and across the seasons as well. In fact, weather can have a very big bearing on it. But what we did take a look at was the grass yield data from the Grass Check programme over the last 10 years. And typically what we found in Northern Ireland is that our average response rate to every kilogram of nitrogen fertilizer we're applying, we get about 20 kilograms of grass dry matter back. And so our question really is, going forward, if we are applying 1 kilogram of nitrogen fertilizer and it's costing us more to do that, is that 20 kilograms of grass feed value worth it? Are we getting more value there in terms of the grass feed than we are in what it costs to sow that kilo of nitrogen fertilizer? So if we move on to the next slide, please, Gillian. So really, when we're evaluating the cost benefit of fertilizer application, that's what we're weighing up. We're comparing the relative feed value of grass produced versus the cost of the fertilizer. When we're talking about the relative feed value of the grass, how we're doing that is we're saying if that ton of grass supplied a certain amount of energy, what would it cost us then if we were to buy that in terms of concentrate feedstuffs? So what we're doing in these calculations is we're assuming a concentrate price of £300 a tonne, a grass quality of 11.3 ME, which is taken from our grass check farm average, and a grass utilisation rate of 80%. And we put this in a ratio, so the feed value of grass compared to the cost of fertilizer. And if we got values greater than 1, then the grass feed value is greater than the fertilizer cost. And so in that scenario, certainly it's more economical to be applying fertilizer. If we're getting values less than 1, our grass feed value produced is less than the fertilizer cost. And so in that scenario, it's not economical really to be applying fertilizer. Next slide, please, Gillian. So what did the results show us? Well, if we look at the graph here, we can see some quite significant trends. So on the bottom line of the graph, we've got canned fertilizer price rising from 300 to over £1,000 per tonne. And on the left-hand axis, on the vertical axis, we've got our grass value to feed cost ratio. Now, if the lines fall within the grey area, that means our grass feed value is greater than our fertilizer cost. If they cross into the blue area at the bottom of the grass, our grass feed value is less than our fertilizer cost. So in that scenario, it's not economical to be applying fertilizer. So what we can see, first of all, is that as our canned fertilizer cost rises, all of our lines on the graph do fall as that fertilizer cost rises. So if we take can at £300 a tonne, the grass value that we get is typically in the region of about 5. Our ratio values are about 5, 4.49 to 5.68, depending on which line that you're looking at there. So what that means is that £300 a tonne, the feed value that we're getting out of that kilogram of nitrogen fertilizer that we're applying is 5 times greater than the cost of the fertilizer. Unfortunately, as can moves to £600 a tonne, that ratio decreases to somewhere in the region of about 2.5. So in that scenario, at £600 a tonne, the feed value is still greater than what it costs for the fertilizer, but it's only about 2.5 times greater than the cost of the fertilizer. So our margins there are starting to reduce a little bit. And so the other thing that we can see from the graph is that as application rate increases, the grass value to fertilizer cost ratio decreases. So the orange line here is an application rate of 150 kilograms of nitrogen per hectare. The purple is 200 kilograms of nitrogen per hectare, and the blue line is 250 kilograms of nitrogen per hectare. So what we can see is that those slightly higher fertilizer cost values, or at those higher, fertilizer application rates, we're getting a slightly lower grass value fertilizer cost ratio. But importantly, in this scenario, and all curves are still remaining above that sort of critical value of 1. So we are getting slightly higher feed value back than we are than the cost of the fertilizer. If we move on to the next slide then, please, Gillian. And if we look at urea, it's a very similar story. So if we look at urea at £400 a tonne, we get somewhere in the region of about 6.5 times the value in terms of the grass value back compared to what it's costing us to spread the fertilizer. But when that urea value, or that urea cost, rises to £800 a tonne, again that halves and reduces to about 2.9 to sort of 3.6, depending on which line you look at, in terms of the feed value to fertilizer cost ratio. But again, in all scenarios here, we see as application rate increases, grass value to fertilizer cost ratio decreases, but then as well, all curves still remaining above that ratio of 1. So in all scenarios here, we still are seeing a better return from the fertilizer in terms of the feed value of grass produced. Now, that was modelled with data under fairly good conditions. So we've got good soil pHs, we've got good soil, we've got good growing conditions, and that was the data that was used, or that was the scenario that was used in that model. But when we start to think about looking at nitrogen response, and I mentioned it earlier, nitrogen responses to, or grass response to nitrogen fertilizer is quite highly variable and can be influenced by a whole range of factors. And Gillian, if we move on to the next slide, please. What we see is that it can be influenced by a range of different things. And these can have quite significant bearing then on actually that value that we're getting back from that fertilizer. So for example, soil health can impact quite significantly on how grass responds to fertilizer application. Sward composition as well, if we have a high content of docks in our field or more native grasses, creeping bent, you know, in the sward, the more native grasses, Yorkshire fog, the more native grasses that we have there aren't designed to respond to nitrogen in any way near the same as the perennial rye grasses that we use today have been bred to do so. So we're not going to get anywhere near the same nitrogen response there. Time of year can have an impact in application conditions as well at the time of application. You know, roughly in around the springtime, for every 1 degree increase in temperature that we see, we tend to get back somewhere in the region of 5 to 6% more nitrogen is recovered in the grass. So certainly time of year and weather conditions can have a big impact as well. And just to look at that in a little bit more detail, Gillian, if we move on to the next slide, soil health, as I mentioned, has a big impact on how nitrogen fertilizer or how grass responds to nitrogen fertilizer. For example, poor soil structure can impact on it. Some data from SRUC in Scotland has shown that when soils are compacted, less of the nitrogen fertilizer that is applied is taken up in the grass and more of it is released to the atmosphere as nitrous oxide emissions. If we have soils with inhibited biological activity, we can again see that nitrogen uptake by the plant is inhibited. And soil pH status is a really big one. This is some data on the left-hand table from Michael Egan down in Chuggas. And he's shown that at different soil pHs, we get different levels of fertilizer use. So at soil pH levels of 5 to 5.5, our nitrogen utilization is only 77%. So we're not getting full utilization of the nitrogen fertilizer that we apply. And in fact, we can waste up to as much as 32% of our fertilizer. So, and that has an impact then on those cost benefit ratios that we were talking about earlier on. This time when we look at the table here, we can see across the board, if we've got a soil pH of 5 to 5.5 and we're getting less or poor grass or poor nitrogen utilization, we see that at those higher costs of CAN, we are getting ratios which are getting closer to that critical value of 1. So we can see at those high fertilizer prices and higher application rates, 1, 1.2, 1.4. So in that scenario, we are creeping closer to that fertilizer not being economical to apply. Next slide, please. And I mentioned as well that the impact of time of year on the cost benefit of fertilizer application. And certainly we've had a look at our grass check data to see typically what sort of nitrogen responses we get at different times of the year. And the table on the left hand side, sort of the second column over, shows for each month of the year the typical nitrogen response rate that we're getting, or grass growth response rate that we're getting. So how many kilograms of grass dry matter are we getting per every kilogram of nitrogen fertilizer that we apply? And you can see in March on average over the last 10 years it's been quite low at 4. And that has a real impact on in terms of our ratio in terms of feed value to fertilizer price ratio. We can see that actually when we're getting responses of only 4 kilograms of grass dry matter, in those scenarios we're really failing to get above that critical ratio value of 1. So we're not getting the cost benefit back. But the one thing I think we would all sort of acknowledge is that we're getting much more volatility in the seasons now, both within them and between seasons as well. And if you move on to the next slide, Gillian. If we look in more detail at the grass growth rates that we've had in March over the last sort of 10 years or so, we can see growth rate conditions anywhere for 2.5 kilograms of dry matter per hectare per day up to 34.5 kilograms of dry matter per hectare per day. In March time, really what we're seeing is soil temperatures being quite limiting and day length limiting in terms of light levels. But that data, when we look at the variability in the data, we see there are instances, there are sometimes in March where we can get really good grass growth. And in that scenario, then nitrogen fertilizer application looks much more appealing because we're much further away from those below 1 ratios. But similarly then, in the months where we expect to get really good grass growth, what we've seen in recent years is that impact of drought conditions. And if we roll back to sort of June and July 2018, in that stage, we recorded grass growth rates of 17.5 kilograms of dry matter per hectare per day, well below what we would expect at that time of year on our plots. And farms recorded even lower than that. And that's really been inhibited by soil moisture. So again, we can't take anything for granted anymore in terms of the time of the year. Although March tends to be a riskier month to apply fertilizer, equally there will be times throughout the year because of the weather conditions that again we need to question that fertilizer price and cost and feed value cost ratio. And so the one thing I would say then to do is take a look at the latest weather data, which is on the GrassCheck website, and also the GrassCheck grass growth forecasts do build in the weather forecast for the next 2 weeks and give a prediction of grass growth, and that will give an indication as to the likely potential response to nitrogen fertilizer. So if we just move on to the next slide, I just wanted to finish up there, but really I suppose for myself, sort of what we've been finding is obviously recent fertilizer price increases have had a massive impact on the cost of producing both grazed grass and grass silage. However, when we look at the economics of it, good quality grass does remain the cheapest feedstuff that we have available to us here in Northern Ireland. And in many of the scenarios that we've modelled, actually the ratio of grass value to fertilizer cost is still positive. And that's primarily given the high cost of alternative feeds. You know, if we're buying in concentrate to replace that energy, obviously, then that's leaving our grass in a very good light. However, that said, the increase in fertilizer price is significant and it's going to add an awful lot to the cost of producing grazed grass and grass silage. So if we do want to get maximum bang for our buck in terms of any fertilizer that we apply, it's really important that we make sure that we try and maximize that nitrogen response. And to do that, we need good soil health. We need to get our timing of fertilizer application right so they're not coinciding with times of poor weather, and we need to optimize our grass utilization as well. That's all from me. Thank you very much. I'll pass back to Sinclair.
Okay, thank you very much, Debbie. A lot of good information there, and I'm sure there'll be a lot of questions, but we'll aim to come back to those at 9 o'clock and pick them up later. We'll move on to our next presentation, which is from Debbie McConnell. Debbie is a senior agricultural technologist at CAFRE, providing guidance and advice on nutrient management planning. And Debbie's paper will focus on the importance of nutrient management planning for best use of fertilizers and animal manures. Over to you, Debbie. Thank you.
Thank you, Sinclair. Just checking, can you hear me?
Yes.
Yeah.
Yes, all good. Thank you, Elaine.
Thanks, Jason. Yeah. Okay. Thank you, Sinclair, and good evening, everyone. From a nutrient management point of view, I'm going to take you back to basics and look at areas of the importance of carrying out an assessment of soil nutrient and soil health status, look at the value of nutrients on farm, the advantages of using a fertilization plan, how to apply nutrients to optimize their potential and achieve maximum effect, and the key rules and regulations to be mindful of. So next slide, please. Soil analysis has never been more important and is a starting point for working out crop nutrient requirements. Knowledge of basic soil fertility will allow you to correct your pH and maximize the use of slurry and target manures at low phosphorus and potassium index soils where they're most needed. A soil analysis service is provided through the DERA Direct offices. Simply phone or email to order sampling kits and borrow soil augers. Sample every 4 years, taking random cores across the field or group of fields up to 4 hectares in area. Next slide, please. Building on what Debbie has said, this slide again shows the effect of pH on fertilizer efficiency. as pH increases from 5 to the range of 6 to 6.5. A greater percentage of the nitrogen, phosphorus and potash applied will be utilised by the plant and less fertiliser will be wasted. On the right-hand column, you can see the potential financial loss resulting from low pH, which is a significant figure at today's fertiliser prices. Next slide, please, Gillian. Soil structure is also very important. You really don't want anything to impede growth this year. So get the spade out, look for compaction, any panning, and any areas of poor grass growth. Soil structure directly affects the movement of air and water through the soil profile, which in turn affects biological activity, crop establishment and root development, and also tolerance to environmental stresses such as drought mentioned by Debbie earlier. Doing a simple worm count can be an indicator of the soil health and the biological activity going on in the field. By doing a sward assessment, potential yield losses can be identified. For example, problems with field drainage or weeds such as weed grasses or docks. These, weed plants are feeding off the nutrients in the soil and will ultimately reduce grass yield. Short-term action should be taken to rectify these problems, such as unblocking drains and controlling weeds. Next slide, please, Gillian. Organic manures such as slurry, farmyard manure, poultry litter, and anaerobic digestate are valuable commodities this year and should be assessed in terms of the nutrients that they will supply. Using standard figures and looking at a typical 6% dry matter slurry, we can see that 1 kilogram of nitrogen, 0.6 of phosphate, and 2.3 kilograms of potash are supplied in every cubic meter of slurry. This equates to 9 units of nitrogen, 5 of P, and 20 units of K in every 1,000 gallons applied. This is assuming spring application using low emission spreading equipment, the nitrogen availability of 40%, phosphate at 50% availability where you have a P index of 2 or greater, and 90% potash availability. Next slide, please, Gillian. Now, last year, I was telling farmers that they needed a fertilisation plan to fulfil the requirements of the Nutrients Action Programme and comply with the regulations. This year, the emphasis has changed. Do you need a fertilisation plan to show when, where, and how much manure and fertiliser to spread? The CAFRE crop nutrient calculator satisfies the NAP requirements and provides farmers with a simple and easy to use fertilisation planning tool. The calculator is available on their online services and can be accessed via the Government Gateway account. Next slide, please, Gillian. Within the calculator, step 1 is entering your field details and soil analysis results. And then step 2, select the crop, for example, grazing or silage or any arable crop. The manure and fertiliser function, which is highlighted, provides an instant crop recommendation and allows you to input various combinations of organic manure and/or chemical fertiliser to be applied during the season. Next slide, please, Gillian. The calculator will provide the maximum crop recommendation for your chosen crop. In this case, it's first cut silage in a 3-cut system on a 2+ P index and 2- K index soil. Please note that this is the maximum recommendation to achieve the highest yield for a silage system. So in this example, it's aiming to achieve high digestibility silage at 12 to 15 tonnes of dry matter throughout the year. If you're expecting a lower yield or lower quality silage, then you should apply less nutrients. It's important to match nutrients applied to the crop yield expected, as excess nutrients will either be held in the soil or more likely lost to the environment, and this is a waste and a cost to the business. Next slide, please, Gillian. This section allows you to add organic manures. You can select the type of manure. the volume to be applied, the method of application, and timing. And all these factors will affect nutrient availability, in particular nitrogen. And using this section here will help you to maximize the potential of your slurry by adjusting rates and methods of application. Next slide, please, Gillian. Similarly, to top up with chemical fertilizer, select the type of fertilizer from the drop-down menu and enter the quantity to be applied in kilograms per hectare. If there's a particular manure that's not listed or fertilizer, there's also a section there when you can put in the analysis details of the manure or the spec of the chemical fertilizer as shown in the boxes. Next slide, please, Gillian. Here we can see the total nutrients to be applied for first cut, both from slurry and from straight nitrogen fertilizer. The bottom line shows the balance of nutrients to be supplied. And had we oversupplied any one of the three nutrients, the system would state oversupplied and highlight the figure in red as a warning. And that's quite useful to keep everybody right to the right side of the regulations. Next slide, please, Gillian. When all field areas and crops have been entered, a summary report can be downloaded. This provides a useful table showing the amount of slurry to be applied across the whole farm and the quantity of each chemical fertilizer required for the season. This will be a very useful tool to plan and budget fertilizer purchases this season. So I would encourage you, following this meeting or some evening soon, sit down, get onto the calculator and use it to plan out your fertilizer purchases. In this example, slurry has been maximized, chemical nitrogen fertilizer has been used to top up the nitrogen requirement, and straight potash has been applied to maintain potash levels. Fairly simple system, and Robert will go into more detail when he comes to farm scenarios later in the presentation. Next slide, please, Gillian. When it comes to application, again, just reiterating what Debbie has said, be guided by the weather. Apply when soil temperature reaches at least 5.5 degrees and grass growth has commenced. And the AFBI grass check is a useful asset for monitoring grass growth and should be referred to. Applying slurry in spring will result in better utilization in comparison to late summer applications. So aim to hit grass at the start of the season as grass growth starts and have the nutrients in place for peak grass growth as the season progresses. Also, don't apply when rain is forecast for the next few days. There's little point in applying nutrients where there is a risk that they could be washed into waterways where pollution could be caused and valuable nutrients are lost from the fields where they are needed. Using low emission slurry spreading equipment will reduce ammonia emissions and increase nitrogen efficiency. Research shows increases in efficiency when using a dribble bar and further increases if using a trailing shoe. Low emission also allows application to heavier grass covers, particularly with the trailing shoe, where grass is parted and slurry is placed close to the ground and there's less risk of sward contamination. Regular maintenance of the working parts of slurry and fertilizer spreading equipment is important to ensure correct application. Very often, calibration of spreading equipment is overlooked, and Chuggas have developed a very simple phone-based slurry calibration tool based on the time required to empty a tanker, the tanker size and bout width to determine the required forward speed for a chosen application rate. This is a useful little tool. Accuracy of application can be improved with the use of technologies such as border limiters, GPS guidance, and variable rate application. Technology which some farmers and many contractors are now making use of. Next slide, please, Gillian. Just to remind you of the relevant NAP regulations, take care to observe buffer zones and no spread areas around fields. Stay 2 meters from all water courses when spreading chemical fertilizer and 10 meters for organic manures or 3 meters if using low emission equipment. But remember, distances for slurry spreading increased during the month of February to 15 meters and 5 meters if using lessee, and maximum application rates are reduced to 30 cubic meters per hectare or 2,700 gallons per acre. A fertilisation plan is required if applying chemical P fertiliser to grassland, high P manures such as pig farmyard manure, poultry litter from laying hens or broiler breeders, or anaerobic digestate to any land. A fertilisation plan must show that there's a crop requirement for the identified P index from a recent soil analysis. Next slide, please, Gillian. So in summary, the take-home messages are, if you haven't already done so, get out and take some soil samples. Use this information to create a fertilisation plan and target your manures where they're needed most and apply chemical fertiliser to top up the nutrients where required. And thank you. Back to Sinclair.
Okay, thanks again, Aileen. And we'll now move on to the practicalities of fertiliser use on dairy farms. And we've got Robert Patterson, who is the dairy technologist at CAFRE, will take us through the options at farm level. So Robert, over to you. Thank you.
Thanks, Sinclair, for your introduction, and thanks to the previous two speakers. I suppose we'll move on to the next slide there, Gillian, please. I suppose this presentation probably seeks to focus more on some on-farm scenarios and see, well, based on the scenario that, okay, we have the bags of fertilizer sitting in the yard and we have slurry in the tank. Where are we going to go, or how are we best going to utilize this these nutrients going forward this season? So just to reiterate what has already been stated, obviously the cost of the bags of fertilizer coming into the yard are not the only thing that are going to influence the efficiency of the fertilizer. It's as much made up on how much grass we can grow as a result of it, and more importantly, how much of that grass can we turn into a saleable product in meat or milk, sorry. So just a few things to recap on before we move on. As has been mentioned previously, the soil needs to be warm enough, preferably 5.5 degrees at 10 centimeters depth. As Aileen says, we need field specific plans. It's no point throwing those soil analysis into the bottom drawer. We need to analyze them, and we need to get plans put in place to maximize the use of our slurry in coordination with our nutrients action plan. Rotational sowing less and sowing more often will help to increase the utilization and the efficiency of that fertilizer. And ideally, as soon as grazing has taken place, to increase the length of time between grazing and the next grazing. As well as our field specific plans, a very valuable thing to be doing this year is to record our fertilizer use on a field basis, how much it got, when it got it. And indeed, if you haven't been measuring grass before this could be a very key year to start doing so. If we're able to record how much fertilizer we're using and match that up with the growth response, it's going to be valuable information for the likes of reseeding, and also helping us to target fertilizer to fields where we're going to get the best return from it. Again, as Aileen mentioned, the store accuracy, the forward speed, the width, the vein settings, all very important and often overlooked. And another thing which potentially you need to focus on this year is the sulfur inclusion in the fertilizer. Sulfur is a key nutrient in grass growth alongside nitrogen. Sulfur price, unlike nitrogen, has remained fairly stable. And today the inclusion of sulfur is probably putting about 10 to 15 pounds a tonne on a 27% canned product. It would be unwise to spend so much money on nitrogen to have grass growth limited by sulfur. Next slide, please, Gillian. So just as we move to look to some on-farm scenarios over the next 2 to 3 months, these scenarios are going to be based on optimum soil fertility, a pH of 6.2 and P and K indexes of 2+. targeting slurry applications between 22.5 to 28 meters cubed per hectare, or 2 to 2,500 gallons per acre, with low emission slurry spreading techniques. And we're also going to be obviously looking at the DARA online crop nutrient calculator. And again, these scenarios are going to be based on optimal fertilizer and grass growth responses, as mentioned previously by Evan. So we'll move on to the first scenario, please, Gillian. So the first scenario is our first cut silage. And first cut silage is going to represent the best bang for our buck in terms of kilo of nitrogen applied across the entire grass growing season. So again, with our soil fertility in mind that we just mentioned, our crop requirements are going to be 120 kilos of nitrogen, 40 kilos of phosphate, and 60 kilos of potash. Now in this scenario, we're going to apply 28 meters cubed of cattle slurry per hectare, or 2,500 gallons per acre, with low emission slurry spreading. And we can see that our phosphate requirement is almost filled here, and we actually have an excess of potash in this scenario. So our deficit here is 91 kilos of nitrogen, which, if we were applying a 27% canned product, is going to equate to 330 kilos of kilo per hectare, or 2.7 bags per acre. Can I get away with sowing less? Some may ask. Potentially, but you're going to run into other issues potentially. As Debbie showed earlier, there's an economic response for sowing this fertilizer, and we're going to get the best response out of our first cut silage. And potentially, we don't know what prices are going to do throughout the rest of the season. But if we're coming out of May with a full pit of first cut silage at good quality, that's going to be a great resource for us and money in the bank. Also worth considering is splitting the fertilizer applications to this first cut silage. This will potentially increase the utilization and efficiency of this fertilizer, and it will decrease the risk of poor weather or soil conditions coming in. We only have to look at last year, and we saw ground frost on the 1st of May. So if we can decrease our dependence on weather conditions being stable, that's going to benefit. However, there are some issues to consider with split applications. Is it going to be realistic or feasible to get on with that second application? And based on your first application date and your proposed cutting date, are you going to have enough time there? And also, what is the grass cover like when you're going on with that first application? Next slide, please, Dylan. So our second scenario is our first grazing scenario, with a projected turnout of February or early March. Similar to the following grazing scenario, the most important point in these scenarios is to get out early and measure the grazing platform and get walking over it, preferably a week to 7 days before any livestock go out or any slurry is applied. There'll be 3 benefits to that. You'll be able to see what individual fields are like. If you're measuring the grass, you'll be able to establish an average farm cover, and you'll be able to budget and see what feed is available for you there on the grazing platform. And thirdly, it'll give you a chance to physically walk over and monitor soil conditions and see where will practically be possible to get slurry to. So in this scenario, we're thinking, look, we can try and displace some early spring nitrogen here with the use of slurry. Obviously, our silage ground is priority for the slurry, but if our P and K indexes are sufficient, then there's no point in oversupplying slurry and wasting the P and K in the slurry in order to get extra nitrogen in there. Potentially, that P and K could be better utilized on the grazing platform. So in this scenario, if we typically have an opening average farm cover between 21 and 2,500 kilos of dry matter, there's going to be a third of those paddocks there that are going to be less than 2,100 kilos. These third of the paddocks would probably be the ones grazed towards the end of the first grazing rotation, and it presents us with the opportunity to get out here early to mid-February using low emission slurry spreading techniques to get slurry, say 22.5 meters cubed per hectare, 2,000 gallons of slurry onto these grazing paddocks, which is going to supply us with 23 kilos of nitrogen. The remainder of the grazing platform then, obviously we want to graze that first before we'd apply any slurry to that to prevent contamination of the sward. But potentially if the first grazing rotation is still long enough, there's going to be the option to get onto those paddocks with slurry, lower rates, 2,000 gallons per acre, after slurry, after grazing, sorry, with the slurry, and supply those nutrients. In terms of fertilizer, Debbie touched on it earlier, on the effect of sowing nitrogen early in the season, sort of mid-February to mid-March is a risky time. And typically for the 1 kilo of nitrogen, we would expect that growth response of 8 to 10 kilos. However, with weather and soil conditions, this could be as low as 3 to 5 kilos, or it could be as high as 12 to 15 kilos. It's just a very risky time. Recent costings have shown that the response that you require for this kilo of nitrogen is up around 9 to 10 kilos. So again, highlighting how risky a period this is to be sowing that nitrogen. In this scenario, however, if we are getting out early and grazing and you're predicting a feed deficit towards the end of March, the start of April, potentially if ground and weather conditions are appropriate, there is an economic advantage of going out here and sowing this fertilizer to fill that feed deficit towards the end of the first rotation, compared with the cost of supplementing the diet with additional concentrate or silages. So in this scenario, would be suggesting get out with 30 kilos of nitrogen, preferably in a protected urea form, and applying that to those paddocks with a greater cover than 1900 kilos, and following this, little and often, rotationally. On to the third scenario then, please, Gillian. So again, the final scenario we're going to talk about here this evening is a slightly delayed turnout of early to mid-April. And again, the most important factor in this scenario is getting out early and walking the platform and seeing what covers are like and where slurry can go. So in this scenario, there's potentially more opportunity to get more slurry onto the grazing platform, depending on your soil analysis and your nutrient management plans. But potentially swards up to 2,500 kilos of dry matter in this situation. If slurry has gone out mid-February, there's going to be a good interval there between slurry application and grazing. And if it's gone out at lower rates, with the 22.5 meters cube per hectare, with low emission slurry spreading techniques, the contamination issue should be decreased. In this scenario, there's little or no requirement for that early spring nitrogen to be sprayed. It's unlikely you're going to need that grass at that time of year when the response is going to come, and it's very unlikely that you're going to be able to utilize it. Whenever you are able to get out grazing, it's those higher covers that you want to be focusing on first. But if turnout is delayed to this time of the year, it's likely that the rotation length is going to be fairly short from the start, and it's probably not going to allow the slurry to be applied to those grazed swards following grazing, as the interval between slurry application and grazing would be too short. Again, apply the nitrogen rotationally little and often thereafter. Last slide, please, Gillian. So the three summary points we have then: only apply nitrogen fertilizer early in the season if you know that you're able to utilize it, and if you know you're going to be able to maximize that grass growth response and the conditions allow. Secondly, apply recommended levels of nutrients to maximize your first cut silage yield. It's going to be the best bang for your buck per kilo of nitrogen, and it's going to be money in the bank going into the rest of the season. And thirdly, focus on controlling the factors within the farm gate that you can control. Maximize all the factors you've heard about this evening so far in your soil fertility and in your application practices, and try and maximize the amount of grass that you're able to utilize. Thank you.
Okay, thanks very much, Robert. Some really useful practical approaches there in terms of maximizing the use of fertilizer this year. Again, just remind everyone to keep entering your questions. We've got a really good range of questions, and we'll be picking those up shortly. And do put them into the Q&A box rather than the chat box, because it's easier to pick them up there. So we move on to our last presentation of the evening, and it's back to AFBI with David Patterson, who's the grassland agronomist at AFBI. And David is going to look at some of the longer term options that we might need to now think about in terms of reducing reliance on fertilizer. So David, over to you, please.
Okay, thank you, Sinclair, and good evening, everyone. I think you've all heard a lot of really good information tonight about how to deal with the impact of rising fertilizer costs and how to react to that at the present and in the incoming season. What I want to do is take a look a little bit further into the future and consider what alternatives there are to using chemical nitrogen fertilizer on grassland. I think by way of introduction, it's also worth noting that there's also, never mind the financial or the economic cost of fertilizer, there's also the environmental cost of chemical nitrogen as well. And as we think and move towards lower carbon farming, one of the mitigations that is available to us as dairy farmers is to take a serious look at how and where we can reduce reliance on chemical nitrogen fertilizer in the first place. And that is one of the ways to help reduce the carbon footprint on any dairy farm for that matter. But back to the talk for tonight, in terms of reducing reliance on fertilizer nitrogen, I think we need to take a look back at our swards and the species diversity that's in those swards, because in the future, to achieve more sustainable grassland, I think we need a greater diversity of species in those swards. And I use the word sustainable deliberately because it has to, as I say, make the physical return and productivity, the economic savings, and the environmental savings as well. And really what I'm talking about is, in the context of tonight's talk and with reductions in chemical fertilizer, it's looking at the greater use of legumes to be able to fix biological nitrogen in our grassland systems, and in particular, looking at white and red clover. There are other legumes available, but those are the two main ones for this brief talk tonight. Thanks, Gillian. And when we think about diversity and how to increase diversity on our pasture, what I'm really talking about is first of all, the photograph on the left-hand side, where we have a very healthy, vigorous sward of ryegrass and timothy in the grass component, and white clover in the legume component. And you can even see there that you've got a greater diversity of species above ground. There's greater diversity below ground as well, I should add. And there's even some pollinators, the bees sitting there on the clover flowers. The right-hand side photograph is taking species diversity a step further and introducing into that same type of sward, maybe as well as grass and clover, adding in herbs or forb species such as plantain and chicory. And that's taking the diversity a little bit further and bringing other advantages to more sustainable grassland as well. Next slide, please, Gillian. But returning just to the first step in that diversity step-by-step process, it's introducing white clover in alongside our grass swards. And some of the features of that, first of all, just a few points here. White clover can substitute chemical nitrogen with fixed atmospheric nitrogen. And I should emphasize that's for free. That is being biologically stored through the nodules on the roots of the clover plants in particular. First of all, that nitrogen is available then for the clover to take up, and by a clever process of nitrogen transfer, which is happening again throughout the growing season, that nitrogen is then available for the grass component in the sward to take up. And when I looked across a range of grassland studies, both in AFBI over the years and elsewhere around the rest of Ireland and the UK, the average atmospheric fixation level in a grass white clover sward is in around 150 kilograms of nitrogen per hectare. So that's the ballpark figure in terms of how much chemical nitrogen can be substituted if you have a healthy clover sward. Second of all, these swards are ideal for grazing, in particular, grass white clover this is, because of the stoloniferous growth habit of clover. You can see in the photograph the plant sort of creeps along the soil surface horizontally with the stolons, and at every node then pops up a stem and some leaf, and that's what will be grazed off, obviously. But that growth habit complements the more vertical type of growth habit of the perennial ryegrass, which is more upright and tufted. So the two complement each other very well, and also complement each other below ground also. Aside from that, there's plenty of reports in the literature showing higher dry matter intakes due to the higher digestibility of the white clover tissue itself, and that's largely due to the lower levels of cellulose and lignin compared with grass tissue, especially over the middle and latter part of the growing season. Next slide, please, Gillian. Just to touch very briefly on red clover, we mentioned it earlier. Typically, the red clover's use is going to be in silage swards. If we're talking about more diverse, more sustainable swards for the future. Relatively short-term swards would have maybe Italian and hybrid ryegrasses as a companion. Longer-term swards lasting maybe up to 8 to 10 years would typically have diploid and tetraploid perennial ryegrass along with some white clover. But the yields and the crude protein that I've put up there, they're fairly typical from local trials done at Crossnacreevy over the years. 14 to 16 tons of dry matter per hectare per year, with an average crude protein of 18 to 22%. Downside of red clover, it only persists in the sward for 2 to 4 years. It's a relatively short-lived species. It has an upright growth habit, which works well for a silage cutting scenario, and it keeps up with the grass plant. But it has this elevated growing point, which is sitting just above ground level, and that's why sometimes with damage done by grazing traffic as well as machine traffic, you can even get lines in the sward where that growing point has been damaged and the plant simply doesn't recover from that. So it's one of the reasons why we have to have a different type of management for these swards looking to the future. Next slide, please, Julian. But can these grass clover swards actually deliver on dairy farms? There's some particularly good work that has been done in recent years down in Chagas Moor Park, and they simply compared side by side 2 dairy herds, one on a grass only situation for grazing and for silage, and you can see that in the middle column, compared on the right hand column with a grass white clover dairy cow system. And I should say both of these systems were compared side by side, same stocking rate, same amount of meal going into the system, and the grass clover swards at typically about 20% clover content. But back to the table, you can see there in the top row, the fertilizer nitrogen was reduced from 250 to about 150 kilograms of nitrogen per hectare for the growing season. But the herbage yield, can these swards deliver? The herbage yield was very similar overall when you compared the grass only versus the grass white clover. The milk solids per cow were actually higher in the grass white clover, which might be a reflection of the higher levels of intake per cow and that higher level of digestibility in the clover tissue. And the overall nitrogen use efficiency, no surprises here, was considerably higher, 37 versus 55 for the grass white clover system. So I think these swards and these alternative systems, yes, this is at a research farm, and it has to be thoroughly tried and tested out in commercial farms, obviously, but the figures and the research trial certainly do stack up in terms of grass white clover swards can deliver in a dairy farm situation. Next slide, please, Julian. But there's always some downsides and the challenges, and I've just listed out some of the key points that I've picked out of the literature over a whole range of trials done over the years around UK and Ireland. And you can see there, less predictable spring yields of clover, although as we heard earlier, obviously grass can be quite variable in terms of its yielding capacity at certain seasons of the year. Second point, yes, you can't deny it, there's less out of season growth with any of the clovers, any of the legumes for that matter, than generally speaking the grass species. They have a higher threshold for significant growth come the springtime. There's a perception of poor clover persistency, and that's especially borne out, as I said earlier, with the red clover. It's just a shorter lived plant, and we can't do a great deal about that. There's also incidents of bloat reported whenever there's high proportions of clover in the sward, but there are also ways of managing that, and it's not compulsory. It tends to be on some but not all farms. And even if you were making a start in terms of the incoming season or the next couple of years, if fertilizer prices keep going the way they are, how to establish clover into both new reseed ground where the sward's worn out, and also into otherwise very productive, good established ryegrass swards. What are the techniques that we need to learn and maybe relearn in terms of how to get that clover into the existing swards? Because the results from Moore Park and all of those other wonderful trials can only be achieved if you have a sustainable, continuous, productive level of clover in the sward in the first place. Next slide, please. So just to sum up, I think these grass clover swards, yes, they're more sustainable, and yes, they can substitute more fertilizer nitrogen and improve the herbage digestibility. That's clear, and that's shown in the evidence. But like I say, there are some establishment and persistency challenges with these swards, and we have to just develop smarter management strategies. And these different approaches to managing these swards will achieve more sustainable swards into the future in order to achieve better cost savings in terms of chemical fertilizer, and also those all important environmental savings at the same time. There, Sinclair, I will conclude.
Okay, thanks very much, David, and thanks to the other three speakers for keeping pretty well on time. And it'll give us now a good chance to address some of the questions. I'm pleased to see a lot of questions coming up in the discussion. I suspect if this was a live meeting, we could be here for another couple of hours yet, but we'll have to manage to address as many questions as we can in the time available. So at this stage, we're going to open the question and answer session. We've got all the speakers, and we should also be joined by Jason McFerrin from CAFRE. Jason, as many of you know, is the Senior Business Technologist at CAFRE, and will address any of the burning issues in relation to farm business planning. So you're very welcome, Jason. So I see we've got 40 questions, and I'm just looking at them here. And there's a really good one here to maybe kick off, and it's probably for you, Debbie. And I think it's a very practical question, which a lot of people will be looking at this year, which is basically, I am planning to reduce my end fertilizer application by 100 kilograms per hectare this year. So that's 80 units less fertilizer being applied, from 250 back to 150. What impact will this have on my total grass production for the year? A really relevant question, and a question that a lot of people are asking. So, Debbie, do you want to maybe have a look at that one, please?
Yeah, okay. So if we are going to reduce fertilizer usage from 250 down to about 150 kilograms of nitrogen, you're probably talking there about a reduction in yield of about 2 tonnes. So at a 250 kilos, you're going to get a grass growth, total grass growth over the season of 11 tonne. If you take that back to 150, you're talking about bringing that down to 9 tonne of grass dry matter produced per hectare. If you then work that up into what that means for a 40 hectare grazing platform, that means you're going to be about in total 80 tonne of grass short compared to if you've been applying a higher rate at 250 kilos, which means that that's going to impact on your stocking rate for that grazing platform. You could take that down from about 3.5 cows to the hectare down to about 2.8, 2.9 on my quick calculations there. So you are going to effectively have to find forage for an extra 25, 26 cows that you've effectively lost. There are ways to do that. You could bring in an additional area into the grazing platform if you have that available to you, or the other option is then to try and buy that into the system as concentrate and buy in that extra energy. But you're talking, I think on my figures, is somewhere in around of about 900,000 megajoules of energy that you've got to buy in to replace that extra forage. That could cost you anywhere between 16 to 20k to do that, depending on the spec of your concentrate. And in contrast, applying that extra 100 kilos of nitrogen fertilizers probably going to cost you in the region about 9k on that 40 hectare platform. So you can reduce it, but you're going to have to pay for it somewhere down the line in terms of you've lost a stocking rate capability on your platform. So you're going to need extra area, or you're going to need to buy in that energy in terms of concentrates, and that could be quite costly.
So the forage budgeting is a really crucial bit. And I think, I mean, a very practical measure, what you've suggested there is 100 kilos less fertilizer or 80 units less fertilizer is 2 tons less dry matter per hectare.
Yep.
So you really need to factor that into the equation in terms of what are you going to replace that with if you're going to keep the same number of stock on the farm. So, you know, I think that's the real dilemma that's facing everyone this year, because there are no simple solutions to that, but at least the data there. And probably also, I think one of the key things is going to be measuring grass to know what your farm is producing will allow you to get a better answer to that as well. So, okay, thanks, Debbie. Well, just moving down through the questions, and I see one there for Evin on the whole. I mean, slurry obviously is so valuable this year, we've got to try and maximize it. And the question is there any merit in testing slurry to confirm the nutrient content? I mean, what sort of variation is there in nitrogen content of slurry, Evin?
Yes, Sinclair, it's a good question. I use the standard figures there, and that's what we use for the NAP regulations. So on inspection, that's what would be used. However, there's a lot of interest. You know, is there differences in the times of year? You know, the cattle diet. You know, is there a difference in the early autumn compared to later in the winter? Or young stock versus older stock, you know, dairy cows versus followers and what they are fed. So it is a useful exercise. The only caveat I put in it is just, you know, can you guarantee consistency and accuracy of sampling? There's the whole safety aspect of taking slurry samples, and we encourage safety first and only to sample, you know, from outside mixing points and only where it's safe to do so. And then getting a representative sample from the tank can be difficult. I suppose the best time is just when the tanks have been agitated, when they've been mixed, and after a period of time to allow gases to settle, take a sample then, or take a sample from the tanker is probably the best. But it's very, very difficult to get a representative sample across the whole tank. So, you know, but yes, it's interesting to compare. So it is to see that variation.
But the practical difficulties are the real challenge. So probably in the first instance, use the standard values unless there's something particularly different about the slurry that makes it that would make it have a different analysis. So
yeah,
okay, absolutely. Just scrolling down, there's a question here. I suppose an optimistic question in some ways. You've mentioned this is for Robert. I think you've mentioned maximizing first cut yield, Robert. Would it not be more cost effective to sow less now and grow larger subsequent cuts, second and third cuts, when fertilizer price declines? Somebody's got a crystal ball there to, I mean, what's the likelihood of fertilizer price declining? Unfortunately, it doesn't look that promising at the moment. So Robert, any comment?
No, as you say, nobody has crystal balls, and that would be ill-advised for me to sit here and say otherwise. I suppose as we said numerous times, and Debbie backed up with her point there of reducing the nitrogen applications, we are going to get best response from our first cut silage, and we are going to get better response from our grass in terms of a cheap feed, and compared to making that shortfall up in other ways. That sort of talk has been heard out about the country, that farmers think that fertilizer price might decrease, and if we take a small first cut, we can maximize later cuts, but a very risky strategy. And for me, I'd want to be going into the later summer period on the best foot forward, knowing that you had a good supply of first cut silage in the bank.
Okay, but I suppose pragmatically, it probably makes sense to only buy enough fertilizer to do the first cut at this stage, and make the maximum use of that, and hope that fertilizer prices will hopefully go down slightly later on, but at least you're not committing to that. But you've still got to make maximum use of fertilizer for the first cut. There's an interesting question there from Stephen McElroy, who's in a 3-cut system. And it's saying, should I move from a 3-cut to a 2-cut system, obviously to reduce the fertilizer use? Previously, first cut was taken on the mid-May fertilizer dates. If he's moving to the 10th of June cut, obviously there's going to be an impact there on quality, which needs to be taken into consideration. Robert, do you want to, or Debbie? Maybe Robert first.
No, feel free to chip in, Debbie. But yes, I would imagine the quality of your forage is going to decrease, obviously, going from the 3-cut system back to the 2-cut system, and it's the cost that making up that deficit in quality is going to be through increased meal feeding. Obviously, you need to take that into consideration. Yes, your harvest costs will be slightly lower, and your fertilizer use might be slightly lower, but that's a short-term outlook on a longer-term problem going into next winter. Any other thoughts,
Okay.
Debbie?
No, I think you're spot on there, Robert. I mean, in doing that, if you do push that first cut date back, the loss in quality could be quite significant there. And it's not only quality in terms of energy, but it's quality in terms of protein as well. And obviously that is incredibly costly to buy in. There's been some work done at AFBI a number of years ago looking at silage production on commercial farms. And when nitrogen fertilizer actually was reduced down below what was recommended by RB 209, you could see anywhere from a half a point to a full point percentage point reduction in crude protein content of that silage that was then made. So that, that will be significantly costly then to purchase later on.
Yeah, it's saving cost now, but perhaps having to spend more later to make up the difference in terms of silage quality. Yeah, and I mean, one of the big unknowns in all of this is that fertilizer cost is also affecting the grain growers. So, there is a potential, hopefully not, but certainly, impact on crop yield if grain growers use less fertilizer as well, could have other consequences. But that's maybe looking too far ahead at the moment. And one question here, maybe for you, Debbie, it's a good question. The feed value ratio or the economic benefit in March is surprising. Does that mean the early spring grazers, such as in the south, are wasting fertilizer and getting it out early? In February and March, you were showing a low response there in some situations.
Yeah. So what we looked at from the sort of the average of the grass check data from the last sort of 10 years, we got an average nitrogen or grass growth response rate of 4 now, and in 16 in April. As Robert mentioned, probably to be about cost effective, you want to be looking at sort of getting at least 9-10 kilos of grass per kilogram of nitrogen fertilizer applied. So we're sort of, once we get into April, we're not too bad, but once we're in March, that can be sort of significantly lower. But I think it all depends on, rather than the month of the year, on the conditions immediately following application in those 2 weeks really after we've applied that fertilizer. Because as we've seen, we've got grass growth responses. Sometimes we've got grass growth in excess of 30 kilograms of dry matter per hectare in March, and then, as is shown on the slides, in July we've got grass growth of 17 kilos of grass because of drought conditions. So I would say rather than focusing on necessarily the month of the year, it's really what are the weather conditions in the next 2 weeks to be like. And I think particularly in March, I mean, the biggest thing that we see in March inhibiting grass growth response is soil temperatures. And once we can get soil temperatures up above 5 degrees, obviously then we're going to be more likely to get a better grass growth response, because we see that initiation of grass growth at that stage. So if we are sort of down in the south, early spring grazers, if they are in conditions where they can get good grass growth response at that time of the year, because soils are drier, it's a wee bit warmer, the growing season comes a little bit early, then it can be cost effective to apply in March. But if we're on very wet, heavy land where the growing season starts a little bit later, it does call it into question at that time.
Okay, 2 questions here on grass check, one for Debbie first and one for Robert. Aaron McKenna, could predicted end response rate from model values be added to the weekly grass check bulletins?
Potentially, yes. But what I would say is there's huge variation. So we can do it based on the modeled plots and we have the data there, but there is huge variation between individual fields and individual farms, depending on soil type, depending on the type of grass that you have. So we can potentially put out figures. It's just they've got to be taken with a pinch of salt if you're going to apply them to your farm, and make sure, because we are working on data from plots where we have the correct soil pH in place, the correct soil the correct P and Ks in there as well. So it's just, we just need to bear that in mind.
But it could be useful as a guide in terms of if you have good pH status, all the good sward type and so on, at least it will give an indication of what the response is like. So
Yep,
might
definitely
be useful. And one then for Robert, I've forgotten, I think it's from Andrew Crawford. Could CAFRE introduce T-sums? That's going back a good few years ago. T-sums Farmers Weekly, that was what, back in the day, 20, 30 years ago. But T-sums were used to indicate when optimum time for fertilizer application in spring. Is that still worth considering, or are you better just to use a soil thermometer, Robert?
Yeah, but potentially it's a useful thing to have out there in the published press. I suppose I'll reiterate the point that Debbie just made. You know, there's going to be huge variation. I read an article there last week, and one farmer went out to a field, and it was a south-facing field, and the soil temperature was up 8-9 degrees, and he went around to the other side of the field where it was north-facing, and it was 4.5 degrees. So you know, there's huge variation over very short distances, never mind across the country. Yes, soil moisture soil temperature probes, great little bits of kit, relatively inexpensive, and can provide you maybe that reassurance you need on the spring day.
Okay. Yeah, I've got one here. Sorry, I've just missed it. It's from Robert Fife, and again, a good question. Coming back to you on this one, Debbie. We'll move on to clover and manures in a minute. We'll take the pressure off. But the cost price benefits that you showed for graze grass, do they alter much when you're looking at silage systems? And is there a place for multi-cut silage systems? The same question as before at present fertilizer costs. So probably the first part is, do the cost price benefits change much with a silage system?
So we didn't really look specifically at grazing and silage. We looked at sort of the nitrogen response at a given level of fertilizer application. So that should fairly well apply to both grazing and silage systems. I suppose when we talk about multi-cut silage systems and sort of getting upwards of 4 cuts, in those sorts of scenarios, obviously fertilizer is a bigger proportion of the total overall cost. I think in a 4-cut systems, it's roughly in around 21% of the overall cost. So the more cuts we go to, obviously the more susceptible we are to increases in fertilizer price rises. But as we've already talked about, you know, the more cuts we have, the more opportunity we have for putting high quality forage in the clamp, and higher energy quality in the clamp. So it's that trade-off between really good quality forage for the winter period versus a little bit extra energy or extra expenditure, on fertilizer at the moment.
Okay. Again, a good practical question here from Cormac McCurvey. I think it was Avine or perhaps Robert who mentioned compaction and the fact that that can limit the grass response to fertilizer. Would there be benefits in looking at it this year to improve in uptake? Would the benefits outweigh the cost given the increased price of fertilizer? Aileen or Robert, do you want to?
Well, Sinclair, anything that improves soil structure should be encouraged. Although, you know, you do want to make a good assessment of the soil structure problem before going in to take any remedial action. So digging a good soil pit and looking down the soil profile to see where the problems are, and then taking appropriate action. But I would be in favour of anything that can improve soil structure and relieve any compaction that's there to promote, you know, good grass growth again within the field area. Do you want to add anything, Robert?
No, just that, as Aileen said, reiterate the point, it needs to be tailored, and sometimes in some of the soil compaction alleviation measures, they can result in very heavy machinery traveling over ground when conditions are not ideal, and in some cases, you know, creating more issues than they're solving. So it needs to be looked at on a field by field basis.
Yeah, certainly I think the evidence in terms of the impact of aeration is quite variable. You need to get the conditions just right in terms of soil conditions and so on to get the benefits. And as you say, Robert, sometimes you can do more damage if the conditions aren't right. Question for you, Robert, again here on sulfur. You mentioned sulfur. Is that recommended for first cut, second cut, or third cut, or all cuts?
Yeah, no, I think first cut and second cut, definitely. And yes, there's going to be a need for it in third cut, but I suppose maybe weighted towards first and second cut. A rough rule of thumb is for 4 parts nitrogen, there should be 1 part sulfur. And there has been numerous studies suggesting that that inclusion of sulfur over first and second cut silage represents a 10 to 15% increase in yield.
Okay, yeah, very useful. I'm just going through here, trying to pick up the most relevant questions. There's quite a lot. Question here from Richard Moore: do protected urea fertilizers have a detrimental effect on soil pH? Obviously, given the importance of soil pH, it's critical to ensure we're keeping that well above 6. Aileen or Robert, do you want to comment, or David?
I certainly haven't come across any evidence of that. The studies we have done have looked, in fairness, more at the grass productivity, the chemical composition of the grass, and the yield, obviously, but haven't come across any negative impacts on pH at this stage.
Okay, and I'd be surprised. I mean, the protection is unlikely to have an impact on the response. Okay, I'll pick up a Clover one here, David.
Okay.
There's one asking for how Clover works, but I think you can explain that another day. That could probably take in terms of the fixing. Would it pay to sow clover in the spring, or when is it best to stitch in clover to get the benefit this year? A challenge to really get any benefit from clover in the current. That's more of a long term, but thoughts on that, David?
Yeah, generally speaking, I think on the balance of previous trials, my own experience, and farmer feedback, spring better than autumn, simply because you've got the longer, warmer days ahead of you. When you sow in the spring, there's always a snag, and the downside is there's likely to be a greater population of broadleaf, what you might call soft weeds, which will appear in any spring reseed. So you just have to be prepared to cope with that. Doesn't necessarily mean spraying. It could be strategic grazing or big baling, perhaps, if there's a profusion of soft weeds comes up with the grass and the clover. So short answer, spring would be preferable, April rather than August.
And another clover question here, David. One of the big challenges, obviously, is clover's poor growth in spring. How can a dairy system compensate for clover's lack of growth in spring?
Yeah, that gap period where the clover isn't growing and fixing nitrogen and all of those wonderful things, and yet the grass could be growing earlier. That is a problem if you're totally reliant on a grass clover sward, obviously. But when I was down recently talking to the folks down at Johnstown Castle, and they are actually converting part of their dairy unit to grass clover, they were planning, they've had a couple of years of experience, I should say. They are building up greater amounts of grass clover silage stock to buffer through that spring gap period, and also tactical use of an early input of a moderate amount of artificial nitrogen in the spring period, say 30 to 40 units in the spring, to boost the grass growth. And it almost connects back to one of Robert's comments, that early season nitrogen input. You have to be prepared then to obviously utilize that well, which means getting it grazed off. Otherwise, the grass that you've boosted in the early season to counteract the spring gap will only compete too strongly with the clover and the sward. So it's trying to solve one problem, you create another. But I think as long as it's well utilized, you can ride through that spring gap.
Okay, thanks, David. We'll take two more questions, just a very straightforward one here. Given the importance of soil pH, and Debbie and Davine both showed how fertilizer response or efficiency is reduced at lower pH. Question here is it better to go for a pH of 7, probably on the high side, but is it better to aim above 6.5, let's say, as opposed to aiming for pH of 6? Is there any evidence, as you get above 6, 6.3, is there any benefit in going above that with more lime? Debbie, do you want to go first, maybe, and Davine?
Yeah, so obviously from the studies that have been done over the years, about 6.3 has been sort of defined as optimum for grassland systems. I suppose if we're going slightly above that, there's not too much impact in terms of nutrient availability and nutrient uptake. But if we do get into very high pH soils, then we get, for example, more calcium in the soil, which if we've got issues with phosphorus, it can lock up some of the phosphorus. So once you get into the extremes at either end of pH, you do end up in scenarios where you're reducing the amount of your main nutrients available. Going up as far as 7 shouldn't have too major an implication, but there's really no additional benefit to it over and above that of the optimum of about 6.3 at the minute, as far as I'm aware anyway.
I think, Sinclair, some of that debate comes from the fact that in the south, their recommendation would be slightly higher than ours. They would be pushing, to that 6.5 and above. But as Debbie says, there's no evidence for us to change our recommendation yet. But if that evidence, becomes becomes available, it'll be looked at again. So.
Okay, another one on lime. I'm just picking up from Neville Graham on the chat box. Given the current conditions, if lime has been spread, how long before fertilizer application should take place, particularly if it's urea-based fertilizers? I know there is some evidence around impact of liming on inefficiency. Debbie, do you want to pick that one?
Yes, so there's a couple of things to bear in mind with lime. So lime and urea, if you're applying urea first, then there's no issue with applying lime afterwards. You roughly want to leave about a 10-day window just to be sure. But if you're applying lime first, that can inhibit the use of the urea. So you want to wait actually somewhere as much as up to 3 months. So in reality, if we are thinking about applying lime, actually, in particular to silage swards, it's actually better done towards the end of the season, because when we are thinking about silage swards, some of the particulate matter from the lime can inhibit the ensiling process. So if we're applying lime in the spring and then trying to ensile a sward pretty soon after that, that can have knock-on impacts there. So yeah, urea first, then lime at the minute, about a 10-day gap. If you do need to do lime first, then you've got to wait for about 3 months for urea application.
Yeah.
Okay, very useful. Thanks, Debbie. And we'll maybe take the last question, which is from Aidan Cushionhan, and I'm pleased there's a question for Jason, as he's been on the panel. Any comments on how I should organize my budget to allow for increased fertilizer price? Really important question in terms of, how do we deal with the real practical issue of a much bigger budget requirement for fertilizer this spring. So Jason, is that one you would like to address, please?
Okay, I thought I was going to get away easy there this evening, just listening. Yeah, obviously as fertilizer prices have maybe tripled in some cases, that means if we do everything the same as we did last year, we're going to triple the amount of money we need as well. So from a cash flow point of view, if we're going to be able to buy that all at once, that might be difficult. From a credit point of view, certainly the merchants aren't able to give as much credit as or as long a credit period as they have in the past. So you're going to need to pay that off, and in a lot of cases you're going to need the money available to pay when you're ordering it, and certainly at delivery, if not shortly after that. So I think some of the points that the other panelists have mentioned, thinking about first cut silage, first of all, getting enough there, getting enough fertilizer on the farm to get you through first cut silage. That'll do two or three things. It'll mean you're only dealing with the payments and the budget for that proportion of your fertilizer. We don't know what's going to happen down the line in terms of the prices going up or down, but at least it'll spread that cost going over a longer period. In terms of if finance is needed, if it is required, if it's tight in terms of cash flow, I would recommend going to the banks early and speaking to them. Certainly, if there's an overdraft facility there, you can use that. Banks probably won't be overly keen to extend an overdraft to pay for fertilizer. So it would be more a short-term loan, maybe a 5-6 month loan, and getting that paid off before the autumn winter time again then.
Yeah, good comment, Jason. And probably better to deal with that issue now than, not buy the fertilizer and end up having to go with a bigger borrowing requirement next winter, which is, which could be a real disaster.
Well, it's spreading the risk, and I suppose so. All being well, prices will drop later in the year, but we just don't know that at this stage.
Yeah. Okay, thanks very much, Jason, and thanks to all the panelists. I'm just conscious of time, and I see the numbers are dropping off here, understandably, after 9:30 in the evening. What we will do is aim to pick up the questions that haven't been answered, and Jason Rankin in AgriSearch assures me that we'll try to address these and put them up on the three websites. That's the AFBI, AgriSearch, and CAFRE websites. For everyone who hasn't had the question answered. I think we've given a fair run through most of them, and apologies to those that we weren't able to address. So maybe if I could just sum up at this stage, just take a second or two to sum up, and again, thank all the speakers. But really just to look at the key messages, and thanks, Gillian. I mean, the bad news is really nothing we can do about it. Recent fertilizer price increases will significantly increase the cost of producing both grazed grass and grass silage. And I think Debbie showed that very clearly in her presentation, the sort of implications we're looking at. But the issue remains, good quality grass is still our cheapest feedstuff. And really, in most cases, even with the increases in fertilizer costs that we're looking at, it's still economic to apply chemical N up to at least 200 kilograms of N per hectare, or 160 units per acre, providing the grass is well utilized. And that is a big proviso. But if you looked at Debbie's response curve, the response to N up to 200, and certainly even beyond that, up to 250, is fairly linear. That's when you're getting the best response. So we're obviously not going to the levels that were applied before, but as Debbie clearly showed in her presentation, the economic reality is it still pays to use fertilizer because the alternatives are all more expensive in the majority of cases. But obviously within that, we want to maximize the grass response from the fertilizer that is applied through good management practices. So even more, it's emphasizing the importance of soil health particularly pH, phosphate and potash. Sulfur, when it's needed, is also crucial and represents good value for money. Timing of fertilizer application, keeping a good eye on the weather, watching the grass growth prediction curve to see when we're going to be in a period of really good growth, because that's when we're going to get maximum response to fertilizer. And obviously, there's no point in growing good grass and then not using it. So that means efficient silage making, minimizing losses in the harvesting and at the silo and at the silo phase during feed out, and also utilizing grass in the field through the grazing animal. And that means good monitoring, good measuring of what's going on, and making sure that the grass that is grown is being utilized effectively. Slurry and manures are valuable sources of nutrients, even more valuable than ever. So we really do need to make maximum use of them. And that's where nutrient management planning, and there's a lot of good tools on the CAFRE website. So there's lots of good information there about how to make best use of slurries and manures. And let's hope this good weather continues that we've had in January. We're not going to get a better start to February. If we can get another week or two of this good weather, then hopefully ground conditions will be ideal once we get through the close period, and we can start to get slurry out. And in the longer term, there's no doubt white and red clover, they've been talked about for a long time, but if fertilizer prices are going to remain above what we've been used to in the past, then we really have to look seriously at white and red clover, given the potential they have to reduce reliance on N fertilizer. But I think a key thing that came out from Debbie's presentation tonight is, yes, by all means, think about reducing fertilizer application. But remember that for every 100 kilos of N you use less, and that was the example Debbie used, or 80 units per acre less, typically you will reduce grass yield by about 18%. So that has to be made up somewhere in the system. So somewhere else you either have to have fewer animals, more acres, or buy alternative feed. And none of the alternative feeds represent better value than grass. So that's the unfortunate dilemma that we're in at the moment. And it really is a case of trying to do everything we can to maximize the value of fertilizer that's applied this spring in particular. And then let's go through and see what the rest of the year brings in terms of fertilizer prices. So again, thanks to all our speakers. Thanks to everyone who has tuned in. We've had a very good response, and I hope the information has been useful. It's the start of, I'm sure, a lot of information that will come over the next month or two. There's lots of advice out there through AFBI, CAFRE, and others who will help talk people through this. And Jason has just flagged up some forthcoming webinars that might be useful. Fertilizer planning for beef and sheep is on Monday, 31st of January, arable conference, then 1st of February, sheep conference, 2nd of February, and Fulmintic, 7th of February. Nitrogen is a big issue on the arable conference on the 8th of February. And then sheep conference, UGS conference, all online again this year. So unfortunately, we're not going to meet face to face for another few months, but hopefully that's something for the future. And then an AgriSearch webinar on the 1st of March, which is multi-species swords, a view from the farm. So lots of good information coming through in webinars over the next month, and it's important to tune into those. And I think there's one last slide, perhaps. Yeah, and that's to remind me that, again, AgriSearch in particular are very keen that you complete the feedback survey. It takes a few moments at the end of this webinar, but again, it helps to feedback to us in AgriSearch whether this is useful. And also if you've got ideas for future webinars, future events that help to deal with the many challenges that farmers face, then we'd be pleased to hear from you. So thanks again, everyone, and I hope the information has been helpful. Thanks to speakers, thanks to those who tuned in, and enjoy the rest of your evening.